So this slide is wanting you to write about the y-intercept. You should be able to look at that equation or look at the graph, either one, and tell me what the y-intercept is. But it's also asking you about domain and range. So I want to do a real quick review with you about what domain and range is, and I can't remember which one. Okay, so remember the domain is the set of x values that you're going to find on your graph. Well, this table right here is a very short, limited table. It's not all of them. So you can click anywhere on a Desmos graph and just move it along and you can see x values. So here are possible x values that you can see. I've gone as far over as negative 9.24 on this way, and on this way I can go all the way up to, let's see how far I can get, 9.04. But remember, I can change my window, and now I can go all the way out here to 40, negative 40, or this way I can go as far as 17, unless I scroll up here, and then I've got 28. I can keep scrolling, and I can go out as there's 32. So, and you guys know that there's no reason why I have to stop. I can go to any x value on the number line that I can possibly get to. So what that means is that all x values are possible. Positive x values, negative x values, decimal x values, fractional x values, any x value that I want to use, I can use. So how do I write that? Well, you've got a couple of choices here. You can, if you want to use words, you say the domain would be all real numbers. That would be one way that you could write it. The domain is all real numbers. If you wanted to use notation to say that, you would say your x values are elements of the real number set. These two things say the exact same thing. If you wanted to use interval notation, we did that at the very beginning of the school year. Interval notation, we would say my x values start on the left at negative infinity and they stop at positive infinity. Okay, so there's saying it in words, that's saying those same words, just using symbols, and this is using interval notation. So that's how we can talk about the domain. Now the range is going to be a little bit different, okay? The range does have, because we have end behavior, this end behavior is a little bit different. We have end behavior, we've got the right side is going up. So that we're used to that. So we're going up on the right. But and it starts off, it looks like it might be going down on the left, and I would agree that it is decreasing over here on the left side, but it doesn't go towards negative infinity, and here's how I can prove it to you. So go back to here, we can see as we move along here, my y values are definitely getting smaller. But if it was going to negative infinity, my y values would eventually have to get negative. Let me move this out of the way here. So you can see right here, if I go all the way out, I'm out here to negative 25. Is my y value negative yet? Nope, it just is 0.01. If I go out here, it's 0.004. Let's move on out here to 56. It says it's 0, but watch what happens if I zoom in a little bit on the y value. I may be going the wrong way. Yeah, no, there it is. So if I zoom in close enough and get my y value, my y axis really stretched out, I can see that even out here at negative 56, while it said 0 a while ago, it doesn't say 0 now. And so if I keep scrolling all the way out here, I could go out here to negative, 1,000, and it's still going to be a number that's not negative, but really close to 0. So what's happening here is that I can't say that my graph is, I can say that it's going up to the right, because this is going to go up to infinity. You saw how big those y values were getting as I was going up. So that's at 15, but if I scroll over here right now, I'm up to 40 now. And if I keep scrolling, my Y values got really big. So I'm up to 63. So I am going up on the right hand side, but on the left hand side, I'm not approaching negative infinity. What's happening is I'm approaching the x axis. So I could say up on the right, but on the left, what's happening? On the left side over here, what's happening? I'm getting closer. Y approaches 0. Okay. So on the right hand side, I'm going up to the right. So if I'm going to use the arrow notation, I could say on the right side, I go up to infinity. But on the left side, and this is not really the range, this is end behavior. So let me talk about end behavior. This is end behavior. So on the left side, my Y values are approaching 0. So what that means is my range is going to be it's going to be values I'm going to write it in interval notation. It's going to start at 0. It's not going to ever include 0, because remember, you when you read domain and range, domain you read it from left to right, and range you read it from the bottom up. So the range doesn't ever really touch 0, but that's the smallest that it gets, is really, really close to 0, and then it goes to infinity. Okay, so that would be one way to say it. Another way to say it would be to say that my Y values are greater than, but they're not equal to, they're greater than 0. And so this is being using interval notation. This is using inequality notation. So these both say the same thing. So for all exponential functions, be sure you see this. This is true for all exponential functions. All exponential functions are going to have a domain of all real numbers, or a domain of negative infinity to positive infinity, because that's what is true. Doesn't matter if it's increasing or if it's decreasing. You can plug in any x value that you want. You can go to any x value and find that x value on the graph. The range is going to change depending on what the graph looks like, and there's lots of changes that can take place, but if it has not been shifted up or down or reflected, if it doesn't have any transformations, then this is going to be the range. When we start doing transformations and we reflect it over the x-axis, or we shift it up or we shift it down, then our range changes. And this axis that we were talking about right here, that place that my graph approaches but it never really touches, that thing has a special name, and it's called an asymptote. Asymptote. So every exponential graph has an asymptote, and that asymptote, in this case, the asymptote is the x-axis. Okay, that's the name of that line. The equation of that line is y equals 0. So the asymptote, the location, the numerical location of that asymptote is going to help you determine your range. Since the asymptote is at 0, then my graph is going to start really close to 0. It's never going to include it. So if it's included on the asymptote, it can't be included on the range. If it's included as the asymptote, it can't be included when you write the range. And it doesn't matter whether you write it like using interval notation. This is interval notation, or whether you use inequality notation. Okay, so for all exponentials, the domain is all real numbers. Doesn't matter how you write it. The end behavior of this particular one is up on the right, and on the left, it approaches 0. It approaches your asymptote. So whatever your asymptote is, that's where it's going to approach. And then your asymptote helps you know where your range starts, or where your range stops, depending on whether it's whether you're going from infinity and stopping when you get to your asymptote, or if you're starting to your asymptote and then going toward infinity. So, but the asymptote is important. Excuse me, important information for the end behavior or important information for your range. It helps you do both of those.